All right. Happy Monday. Good morning. I'm going to be walking you through section 6.3, day 1 today. Juniors, you're going to be gone tomorrow because you're doing your Building Your Future Day. But the rest of the class is going to be looking at 6.3, day 2, and that will also be a video up on Haiku for you to watch and stay caught up on, okay? We are going to learn about vectors in section 6.3. And so I thought it would be funny to start with a little clip from Despicable Me.
Hey, I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah! Hey.
All right. So, like Vector said, a vector has both direction and magnitude. So never give a vector and just say how far you're going. So never say go 3 feet because someone won't know which way to go 3 feet. So make sure that you have not only a magnitude but a direction like northeast. Or you would give a direction as an angle and then the magnitude as like a distance. When you're naming vectors, you can name a vector just vector v, for example, or you can give it its name with its initial point and its terminal point. So this would have to be named vector PQ. PQ, and then you put like a little, it's not a full arrow. I don't know, for some reason it's like a half arrow. If it was a full arrow, someone might confuse it with a ray, which it kind of technically is, but just know that vector PQ is not the same thing as vector QP because those would be going in different directions. QP would be, ooh, it's hard to draw with this thing. Hang on a second, I'm going to start over. Oh, maybe I'll select a line. Okay, QP would be like that. So the arrow goes in a different direction. And that actually brings us to this next part right here. If two vectors are considered equal, they have to have the same direction and magnitude, which seems very like, well, duh. But, all right, to give you an example, you're going to see some problems where you're going to be given two vectors and this one has a magnitude of 3 and that one has a magnitude of 3. And you're going to want to say that those are equal just because they both have the same magnitude of 3. But those are not equal because they go in different directions. Okay, moving on. You're going to be asked to write a vector in component form. And this is the little kind of formula for how you do it. You're going to be given an initial point. We're going to label it x1, y1, and a terminal point where the vector ends. And we're going to label that x2, y2. And then vector component form looks like this. x2 minus x1, comma, y2 minus y1. And then these are pointy brackets. Make sure you use pointy brackets rather than parentheses. If you use parentheses, it would be confused with a point, a coordinate. So if we're talking about a vector, we've got to get pointy brackets. So here's an example. We've got an initial point at 4, -2, and then a terminal point at -1, 5. So make sure you know that it's going from this initial point to that terminal point. Because the thing I'm drawing on is kind of tricky, I'm going to try to use an actual straight line there. That's nice. And you might not be able to see the arrow, so I'll emphasize that. Okay, so initial to terminal. So if we're going to find the component form, our initial point is our x1, y1. Our terminal point is x2, y2. So then our vector, if we call it v, pointy bracket, we're going to do x2, which is -1, minus x1, which is 4, comma, y2. Oh, what did I do up here? Why did I say 2? Did I say 1 and then wrote 2? Oh, whatever. Okay. So y2 minus y1. So that would be 5 minus -2. Okay, so then our vector is going to be -5, comma, 7. That would be component form of our vector. Now, what I just want you to realize is the -5 represents the x component, so the direction that the x value is going in, and then this would be the direction that the y value is going in. So -5, 7 means I'm going 5 to the left, and because this is a +7, up 7. So just take a look from our initial point. We're going 1, 2, 3, 4, 5 to the left, and up 1, 2, 3, 4, 5, 6, 7. So I could have just counted over and up and gotten my vector that way. But there's an algebraic way to do it as well. Okay. Magnitude. If you're asked to find the magnitude of a vector, this would be the formula to use. These are kind of like, they look like double absolute value bars. It's not the absolute value, it's just the symbol for magnitude. We're using the same 2 points, so 4, -2, and then -1, 5. So it's the same vector. And we already found the component form. The component form of our vector on the last page was -5, 7, right? Okay, now if we're told to find the magnitude, we're going to follow this formula, and we're going to do the square root, and then we're going to take the x component and square it, and then we're going to take the y component and square it. So we're going to get square root of 25 plus 49. Okay, which is square root of 74. You could leave it like that, or if you typed it in your calculator, you would get 8.602. So magnitude, I just want you to kind of understand that. Do you remember how we got component form on the last page? We had to do x2 minus x1, and then we had to do y2 minus y1. That's how we got our component form. So if I was to kind of rewrite this, and instead of x, put in the x2 minus x1, you might already be guessing what's going to happen here. I'm going to put the y2 minus y1 in for y. Okay, now you've seen this formula before, otherwise known as distance formula. That's all a magnitude is. It's a distance. So the distance from this point to that point is 8.602. Okay, so we have a vector has both a direction, where you're going, and then a magnitude, which is how far. It's a distance, it's a length. Now, when you're asked to sketch a vector on a graph, you really could start anywhere you want, but I think the general rule would be to start at the origin. So if I was sketching the vector 2, -5, my x component is positive, so I'd be going to the right 2. The y component is negative, so we would be going down 5. So from the origin, go to the right 2 and down 5. Oh, it's so hard to draw on this thing, you guys. Okay, x component here is -3, so that'd be going to the left 3, and then the y component's positive, so it'd be going up. So from the origin, we'd be going to the left 3, and then up 1. Okay. Now, you might be asked to add vectors, subtract vectors, multiply by a constant. There's a couple different ways to do it. I'm going to show you a visual way to do it, and then we'll look at an algebraic way as well. For the visual way, it's called the tip to tail method. So if I'm going to add u plus v, I would start with vector u. And now the question is, when I want to add v, where do I put v? Okay, some people might want to put v right there. But the actual correct way to do it is tip to tail. So I'm going to start my next vector where the blue vector ended, up there. So we started the blue vector here, it went up to here. So now that's where I have to start my next vector. So let me write some stuff in here. Okay, so the blue vector was vector u, the red vector is vector v. If we add them up, their result, sometimes you call it the resultant, would go from the very, very beginning to the very, very end. So this vector, this green one, that's u plus v. All right, let's look at a subtraction problem. We're going to start with vector u again. Okay, now we're actually going to be subtracting vector v. So that means that vector v is going to go in the opposite direction then. So it's no longer going to be pointing to the right. I have to actually flip this. So now it's pointing to the left. It's going in the opposite direction. And then we're going to take that vector and we're going to start it where the blue vector ended. And I need 2 of these v vectors. So I'm going to take my second one, start it where the first red one ended. Okay, so I'm going to label these. Here's vector u. Here's a negative vector v. It's going in the opposite direction. And here's another negative vector v for -2 v's. And then my resultant will be where I started at the very beginning and then where I ended at the very, very end. I'm not even going to attempt to draw that by hand, so we'll do this. We'll see if this works. There. So that would be vector u minus 2v. Okay, so if I had 2w, for example, I would just take vector w and then add another one on, so I have 2 of them going in the same direction. If I had -1/2 w, that would mean that I would need to go in the opposite direction and only halfway. So I'm going to just kind of emphasize this arrow a little bit better. So now if I was going to do -1/2 w, I'm going to start where it ended before, go the opposite direction and only about halfway. That would be -1/2 w. Okay, so what you just really need to realize is when you add 2 vectors, you put one vector down and then start the second vector where the first vector ended. Okay? So let's look on a graph, for example. So I'm going to graph vector v. So from the origin, I'm going to, hang on, I'm just going to get my colors. Okay, from the origin, we're going to go to the left 3, and then we're going to go up 4. Okay, so that's vector v. Vector w needs to start where vector v ended. I'm not going to go back to the origin. I'm going to start where it ended. So it needs to start from here. And then according to vector w, from here I need to go 5 to the right and 2 up. So let me grab my arrow. Okay, starting here, we're going to go 1, 2, 3, 4, 5 to the right and up 2. Okay, so v plus w then will be connecting the very, very beginning to the very, very end. Okay, so from here to the very end. That green one is v plus w. So to figure that out, I could just count over and up, how far over and how far up I have to go to get that green vector. And it's a little hard to see, but that's the arrow. I'm going to add the arrows into the other one. So the blue vector, that's vector v. The red vector, no, go away. The red vector, it's going to do it again. Okay. Started where the blue vector ended, and that's where it ended up. That was vector w. So then v plus w is the green one. If I count over, I had to go over 2 and up 1, 2, 3, 4, 5, 6. So it looks to me like v plus w would be 2, 6. Let's just check that algebraically though, so you can kind of see how, you don't have to always graph. You can just do this algebraically. So we've got -3, 4, and we're going to add 5, 2. So really all I need to do is just add the two x components. So -3 plus 5, that's where the 2 comes from, and then add the y components. 4 plus 2, we get 6. So bottom line is, it's just kind of good to know visually what's happening. But if you want to add them up like this, if that's just easier, which I think it is, go for it. Okay, so if you're going to have w minus v, we're going to have 5, 2, and then we're going to subtract -3, 4. And it's just like distributing in the negative sign. So we're going to have 5 minus a -3. So that would be 5 plus 3, so we're going to get 8. And then 2, don't forget to distribute the negative, 2 minus 4. So that would be a -2. And then don't forget your pointy brackets. They should not be parentheses. If they're parentheses, we're going to think that they're coordinates. And these are vectors, so make sure pointy brackets. Moving on. Scalar multiplication is when you just multiply by a constant value. So if I wanted to do 3 times vector w, I would just take vector w and multiply it by 3. So you can just apply distributive property. 3 times 5, we get 15. 3 times 2, we get a 6. That's it. If you have negative v, that just means you're going to be going in the opposite direction. So basically just distribute that negative sign through. So negative negative 3 would be a positive 3, and then a negative 4. So before we were going 3 to the left and 4 up. Now we're going 3 to the right and 4 down. It's going in the complete opposite direction. And then if you have a problem like this, we're going to do 2 times vector v, and then we're going to add 4 times vector w. Okay, guys, it's just distributing and then combining the x's and combining the y's. I don't know why, but every year when I give this as a test question, people mess it up. So I'm not entirely sure why. Just distribute the 2 through, and you would get, here I'll use red, you would get a negative 6, and then distribute the 2 through, you would get an 8, and then same thing with the blue one, 4 times 5, you get 20, 4 times 2, you get 8. Now we're just going to add up the x components, and we're going to add up the y components. So add up these two x components. We're going to get 14. And then add up the two y components, and we get 16. That's our final answer. If this was a negative sign, you would have to distribute the negative along with the number. It's just distributive property. Should be a slam dunk. And then the last thing is called a unit vector. Basically, the unit vector takes any vector like this one, and it shrinks it down to a magnitude of 1, which you'll see is going to be helpful later when we need to be stretching and shrinking vectors. Sometimes it's easiest to shrink it to a magnitude of 1 and then multiply that out, make it bigger, stretch it. But here's what you're doing. You're taking the vector, that's the original vector, and you're going to divide it by its magnitude. Remember, that's the symbol for magnitude. And this is the formula for magnitude. So if I want this to be a unit vector, I'm going to take the original, 2, negative 3, and we're going to divide it by its magnitude. So we're going to do the square root. We're going to take the x component and square it, plus the y component squared. Okay, so in the denominator, we're going to have the square root of 4 plus 9, which is the square root of 13. Okay, now don't leave it like that. What we really can do is we can divide each component by the square root of 13. So I'm going to do 2 divided by the square root of 13, which I would rationalize. So I would get 2 radical 13 over 13. And then I'm going to take negative 3 divided by the square root of 13, which again I would rationalize. Negative 3 radical 13 over 13. That would be our unit vector. So again, what this has now is a magnitude of 1. So if you took this vector and you found the magnitude using this formula, so you take this, square it, plus this squared, you're going to get a 1. Okay, so that's really the end of the lesson. So juniors, remember, you are going to be gone, but you still need to watch the video for tomorrow. And I just want to go back really, really quick to the very first page. No, not the first page. This page right here. So a lot of the problems going forward were already in vector form, but you're going to have to kind of go back to the beginning in some of the homework problems, and they're going to give you 2 points, and you have to put it in vector form. So just remember this formula, okay? That's it for today. Hope you have a good day, and watch another video for tomorrow. Thanks, bye.